but just a revision from last week. So let's use like the next 5 minutes. Let's do some quick revision from last week. So there are two major trunking protocols. What are they that we discussed last
802.1q
week? Good one.
dot 1q.
802.1q, and then what's the next one?
For the test ISL.
ISL. Thanks very much. And what does ISL stand for?
I shouldn't learn this.
Something.
I don't know.
Inter switch link.
Okay.
Yep. So trunking protocols. Yep. And then what's the difference between 802.1q and ISL?
ISL encapsulates everything,
Yep. Good one.
whereas 802.1q basically restrips and tags.
Yep.
They're both encapsulation methods technically, I guess, but ISL keeps on adding outside the frames,
Mm-hmm.
so it's not as efficient.
And what does 802.1q do?
Um, it actually tags it, or
Yep. Tags it. And what does it tag it with? What's the byte of what it tags it with?
I forget exactly how many bytes. 16 of for the VLAN.
Mm,
That was 4.
yeah, 4 bytes. That's a 4 byte tag.
16 bits, or no?
And yeah,
That's
and
4
which one is for
bytes.
VLAN? Yeah, yeah. So the old
Okay.
tag,
Yeah, you're right.
yeah, it's 4 bytes. So for the VLAN is how many? 16 bits, which
Okay,
is
2 bytes.
two
Okay.
bytes. Yeah, and then part of it is like, what else is included in that tag? What other field?
Mm,
We mentioned this last week. Priority.
okay.
Yeah, priority, which is a 3-bit field, which is used for class of service, or which you can use for QoS. And then we
Okay.
mentioned that the encapsulation. What does it encapsulate? What's the header? How many? What's the size of the header? 26 bytes, and the trailer is 4 bytes. So here's the other question. So when 802.1q tags the frame, it does something else. What else does it do? I would need to mute mute. Yeah, sorry. So when 802.1q, welcome Imran, how you doing? When 802.1q, when it tags the frame, it also does something. What does it do after tagging the frame?
Just-
Or to put it in another way, what other difference do you know between ISL and 802.1q? What are the difference? So ISL encapsulates 802.1q tags, but what's the other difference? Yeah, thanks. Powell is already answered. Yeah, thanks very much. I didn't see your question, your answers, Powell. Sorry, I have one screen today. That's why.
16 bits.
So
Oh,
what's the other difference between ISL and 802.1q that we mentioned last week?
there's a one Cisco and one's a
Yeah,
standard.
that's another good one. Yeah. So let's put that down. So ISL is Cisco proprietary. And what about 802.1q?
Yes. Open format, or
Yeah, exactly. It's an IEEE standard, an open standard. Okay. So what other difference? There's one that I'm also looking for. It's close to the one that Carlos mentioned about ISL and 802.1q. It encapsulates, it tags, but after it tags, it does something. We mentioned last week.
Does it?
We mentioned that because ISL encapsulates, it leaves the frame intact, right? So it does not need to recalculate the checksum.
Oh,
Remember that? Do you remember? Do you remember this, Carlos and Imran um and Mark? Do you remember we mentioned this?
I do now.
So what does 802.1q? So after it tags the frame, what does it do? it recalculates the checksum, right?
Yeah.
Right.
Yep.
Yeah, so it recalculates the checksum because it has changed the frame. Whereas ISL doesn't need to recalculate the checksum because it has not changed the frame at all. So it only has its own checksum at the end of it. So the other thing that we mentioned is the VLAN database. Where is it stored?
On the wait, say it again.
The VLAN database. Where is it stored?
VLAN dat on flash.
Yep, VLAN dat, and it's stored in the flash. So how does it function? Like, if it's stored in the flash, how does it function when the machine is loaded? So this is just revision, quick revision from last week. We mentioned that it is stored in the flash,
It'll load it into RAM after
exactly, but
it
loaded,
boots.
yeah, good one, Mike, but loaded into the RAM. Yep. And what else did we mention last week? We mentioned the different storage areas on a switch. And what are they?
Flash, NVRAM, RAM, ROM,
Yep,
or
thanks.
ROMA.
Flash, NVRAM, ROM, the RAM, and yeah, the flash. What is stored in the flash?
Everything.
Yep, everything like what? Good examples
Um,
like
running config,
yep,
startup config.
running config in the flash.
Mm, no, that's NVRAM, isn't it? Or
Does it get copied to the NVRAM, right? Or is it,
Um, we're revising from last week, so you tell me. So what is stored in NVRAM? What is stored in flash? So Imran is answering. Yeah, good one. Imran said, "I thanks for. Oh, sorry, Powell. I keep missing your answers because I've gone one screen. I'm sorry." So Imran says iOS. So that's one thing to remember. Your iOS, you store it where? In the flash, right? So that's an
yep.
important one because if you want to upgrade your switch, all you do is copy the iOS into the flash, reboot it, right? And then it's going to load the iOS from the flash into the RAM, right? That's all
Right.
you're
You have
doing.
to keep in mind that you have enough space on your flash storage for second image.
It's on some, but I think on newer ones you do. On newer switches, you have more than enough space for more than one iOS.
Yep.
Yeah. So, okay, so iOS, what other one? The one that we mentioned, VLAN.dat. So what about the NVRAM? What is stored in NVRAM?
um, any changes, the current running
Running.
configuration.
Does anyone agree with Mark that we have running config in NVRAM? Yep, thanks very much, Imran. So it is startup config, not running config. So your startup config is stored in the NVRAM, non-volatile RAM, so
Yeah.
that it persists even though you reboot the switch. Your ROM, we mentioned also a few things that are stored on the ROM.
I got half the word right.
What else is stored on the ROM? No problems, Imran, no problems. What else is stored on the ROM that we mentioned last week? Yep, thanks very much. Bootstrap. Yeah, what about the RAM? What's stored on the RAM?
That would
Lot,
be the running config,
lots
right?
of things, yeah, exactly. You're right. Running config. Your iOS is loaded into the RAM. Your VLAN.dat is loaded into the RAM.
Any changes you make
Any
while you're
changes you
working in
made
there.
while you're working on it, yeah, is stored in the running config, which is on the RAM. Yeah, but then if you do copy run start, it saves it in the startup config, which is stored in the non-volatile RAM, which persists even though you reboot the device. Okay, so that's a bit of quick revision from the thing we discussed last week. So going on from there, this week we'll be discussing DTP and VTP. Now, these are really important ones. They're just important foundations. So DTP. So what you understand? We mentioned last week that DTP stands for Dynamic Trunking Protocol. So what's your understanding of DTP? What's your understanding of DTP? What DTP does? Anyone wants to go first?
It tells it whether to be static or not static.
Static or not static? What do you mean by? Okay, so think about it, Carlos. Think about it this way. You're in an interview, and we're interviewing you, and one of the questions we're asking is explain DTP to us.
How would fail. I'm trying to recall. I know this is one where it's not what it actually states. It's not an actual protocol. It's just whether the trunking will be, if you're not setting a static, it'd be dynamic. So that's where you set
Yeah, okay.
trunking.
Yep. Mark, you want to give it a go? Dynamic trunking protocol.
Um, it tells like if that port should be access or trunk or
Yep. So let's put that down.
something like that. I don't know. It's still kind of blurry to me, the whole thing.
Yep. So yeah, so Imran gave another good answer. Imran said link negotiation, but we'll come to that one like in more other thing. Any other thing regarding DTP? So actually, let's bring up a device and let's go to
Alright,
Cisco
so it
switch.
refers to what the port type can be.
Yeah, good one. So let me put that down again. What the port type can be. What the port type can
Basically,
be.
if the dynamics enabled, it'll listen to see if it should become a trunking port.
If dynamic, so we'll explain all this. It will listen to see if it can become a trunk. Okay, so let's go look for a Cisco switch. I like using like pictures like this rather than using just boxes because it helps people to understand things easily when you have nice pictures and stuff. So let's look for a really nice Cisco switch. Yeah, this one's good. So let's copy this and then let's have another whiteboard paint. So think about this, and to explain DTP, we have a network. We have, well, let me see if there's another answer in the chat window. Yeah, link negotiation. Okay. So let's think about this. Let's make multiple copies of switches. So we have a switch here. Um, we have a switch here. And let's have another one. We have another switch here. So here we have three switches. So this is assuming this is not the way it is in the real world because you won't use, I think this is like maybe a 2950 or 2960. You won't use like actually a 2950 or 2960 as your core or distribution layer. Usually you use something more powerful like a layer 3 switch or something like that. And by the way, is how do you tell if it's usually how do you tell if a switch is layer 2 or layer 3? Not all the time, but generally speaking. Is there a way that you can tell if a switch is layer 2 or layer 3? Just to throw that in there.
If it has router capability, it's.
Yeah, I mean from the model number, is there a way to tell?
Oh, I don't know.
Series number, exactly, yeah. So that's one way to tell, although that's not like fully accurate, but that's one way to tell. If you have a switch that is like 29 that starts with a 2, it's usually a layer 2 switch. If it starts with a 3, it's usually a layer 3 switch. For example, you have the 3950, that's a layer 3 switch. You have the 3960, that's a layer 3 switch. You have the 2950, that's a layer 2 switch. You have the 2960. But again, remember that this is not always accurate because you have something like maybe the 4000, is it 4200? And you have like maybe the 6500, which are multi-layer switches, but they are not starting with 2 or 3. But typically, if it starts with a 2, it's a layer 2 switch. If it starts with a 3, it's a layer 3 switch. Is that clear? Yeah.
Yep.
Yeah, and then the other thing, let me see. Yeah, and then the other thing was that somebody made a wonderful post that I shared in the community page, is that if you want to tell if an iOS, if it's a layer 3 iOS or layer 2 iOS, he mentioned that if the iOS is like, LAN,
IP base is layer
yeah,
3.
good one. Did you see that?
LAN base
So
is
if it's
3.
LAN base, what does that mean?
Layer 2.
Layer 2, yeah, good one. If it's IP base, what does that mean?
Layer 3.
Layer 3, but there's a but there.
Um, it's a layer 2 device that has layer 3 capability.
Yeah, it's layer 3. It's got layer 3 capabilities, but it's limited to
It's just
static
like a
routing.
routing engine, but it's not actually a router, right?
No, it does. It has layer 3 capabilities, but it's limited to static routing.
Okay.
Yeah, so if you've got, what does that mean? It's layer 3, right? Yeah, so if it's advanced enterprise, what does that mean?
It actually has routing capability.
Yeah,
It's full
layer
layer 2.
3, but supports dynamic routing.
Hmm.
So you get it. So yeah, I just saw that and I was like, yeah, this is really, really nice and interesting. So that's just some real world scenario. So again, back to this. So we've got our access layer switch here. And of course, we've got our distribution or core, whatever. We've got our core switches here. Again, this is not the kind of switches you should use as your core in the real world. So what you do is typically you have a computer connected to this access layer switch here. So when the computer is connected to the access layer switch, you as a network engineer, you go to the command line and you go to do something like this. You go interface fast Ethernet 0/2, right? And you go switch port mode access, right? What does that mean when you say switch port mode access? What does that mean?
The port won't allow any trunking. It's just for host and terminal.
Trunk will allow what? Sorry, I didn't get that.
I said that it would not be it would not trunk.
It will not trunk. But what does that mean by it would not trunk? What's the underlying principle behind it will not trunk? When you say switch port mode access, so what does it mean?
You won't share VLAN information.
No,
Oh,
Powell is making a good point. Powell said we will not send BPDU, but not really Powell, because okay, yeah, because that depends on if you configure if you what's it called in spanning tree. Because we can configure a port as access port, but if you plug a switch into it, the switch will still send BPDU. Am I right or am I wrong, Powell? I'm not sure. Because the switch will
It only
still send
sends
BPDU.
BPDUs if it's a trunk port that's not currently active, or
Yeah,
it's not a part of the. It's not a designated port, right? And
well,
designated ports still send,
because
but like on a different interval.
BPDU has to do with because you can, for example, I can have a port as an access port. If I connect a switch to it, will the switch send BPDUs to it or not? The switch will still send BPDUs to it. Or am I wrong? His other hand is strong. Yeah, you're right. The answer I was actually looking for is this. When you say switch port mode access, it simply means you can only operate on one VLAN. That's what it simply means. It means you cannot operate on multiple VLANs. You can only operate on one. So when I say switch port mode access, you cannot carry traffic for VLAN 1 and VLAN 2 and VLAN 3 and VLAN 4. It means you can only carry traffic for only one VLAN. And I have to specify which VLAN you're in, right? That's what switch port mode. When you say the port is an access port, it simply means you can only configure it for one VLAN. So after that, I have to go switch port access VLAN 1. So now I've said this port is connected to a computer. I've made it an access port, which means you can only send traffic on one VLAN. You can carry multiple VLANs. And I've put you in a specific VLAN, VLAN 1. But now, like we mentioned last week, we have things that are called uplinks. which are connecting maybe a switch that is on one layer, maybe the access layer, to switches on the distribution layer or switches in the core layer. So let's say these are your two core switches. So you have this one going to this one here. And this is just an example. Again, this is not like absolutely accurate in the real world. Then you plug this one into this one here. Now, these ports that are connecting to this switch here, I, as an administrator, will go on them and say, like, maybe interface gig 0 2 and say switch port mode trunk. What does that mean when I say switch port mode trunk? What does it mean?
So you're allowing the port to carry more than one VLAN.
Exactly. That's like the simple thing behind it. Access port carries only traffic for one VLAN. Trunk port carries traffic for multiple VLANs. So that means it can carry traffic for multiple VLANs. So when I go switch port mode trunk. But here's the thing about DTP is that if I go on a Cisco switch, let's bring up any packet tracer, anyone would be good. So if I bring up a Cisco switch and I go under an interface on the switch. So let's bring up this switch. Let's change the preference so we can see it clearly. Font decline. Let's make it 14. Okay. So let's bring up this switch now. So is this clearer now? Can you see this clearer?
Yeah.
Yeah. So if I go switch interface fast 0 interface sorry, I have to enter the configure mode first. Interface fast 01 and I go switch port mode. Now you can see here that we've talked about access, right? We said access is you're only allowed to carry traffic for one VLAN, and that VLAN will be whatever VLAN would decide for you. So by default, they are all in VLAN 1. Or we can say switch port mode dynamic, which means you can carry traffic for multiple VLANs. By default, you carry traffic for all VLANs, except we do VLAN pruning, and we say you can't carry traffic for this VLAN, or you can carry traffic for this VLAN. So that's sorry, not sorry, my bad. I was talking about trunk, not dynamic. So that's trunk. You can carry traffic for multiple VLANs. By default, you carry traffic for all VLANs, except we prune you and say you can't carry traffic for this VLAN, or you can only carry traffic for this VLAN. But then there's another mode here called dynamic. This is where DTP comes in. Because what this means is that the switch, so when we say dynamic, this is what it means, or DTP or switch port mode dynamic. Switch port mode dynamic or DTP. I hope I've not lost connection again. Okay. So switch port mode dynamic or DTP. This is what we mean. We mean the switch will decide for itself whether a port will be an access port or a trunk port. So that's all it means. It means when we say switch port mode access, we're saying you can only carry traffic for one VLAN and the VLAN will decide for you. Switch port mode trunk, you can carry traffic for multiple VLANs and by default you carry traffic for all VLANs, but you can carry for multiple VLANs. Switch port mode dynamic means this. I'm giving the switch an authority to decide for me whether this port will be an access port or a trunk port. So I'm handing over that configuration ability to the switch. So rather than me going as an administrator, going interface gig 0 to switch port mode trunk or switch port mode access, I'm like, hey, switch, decide if the port will be trunk or access. Now, the way the switch does this is something called DTP packets or DTP frames because it's layer 2. DTP frames. So the switch does this using something called DTP frames. And DTP frames is simply this. So let's bring up another whiteboard. So actually we can see a sample of a DTP frame. Just let's go to um, let's go to sample DTP capture. I'm careful, I'm not sure if I've lost guys again. Hello, can you still hear me?
Yeah.
Ah, okay. Because it's quiet, I'm like, yeah. I'm not sure if it's gone again. So the way the switch will decide whether this port will be, so when I go switch port mode dynamic, it means, hey switch, use DTP to decide for yourself whether it will be access or trunk. But the way the switch will decide is using something called DTP frames. So let's open this in Cloud Shack and let's see what the frames look like. So let's open this. Yeah, here we go. Here we go. And then let's open DTP protocol. So here's what the frame looks like. And then you can see operating administrative, which we'll talk about now. Operating administrative, trunk status, and all that. And then this one. So here's the way DTP frames work. So you have a switch here, and you have a switch here, and you have a computer here. So let's name them so we know what they are. So this switch 1, this is switch 2, and this is PC1. So you go and you connect this port to PC1. And this switch port is configured in mode switch port mode dynamic, which means switch, I'm giving you the authority to decide whether this port should be an access port or or a trunk port. So what will happen is it depends on the switch model. There are some switch models that by default, because here's the other thing, let's mention this. Because when we say dynamic or DTP, there are two modes. There's one called dynamic auto. So just you don't need to understand it, just know that there are two. There's one called dynamic auto. There's another one called dynamic desirable. And we get to all this later. So just you don't need to understand them, just know they exist. We'll explain that later. So there's one called dynamic auto, there's one called dynamic desirable. By default, for some switch models, all the switch ports by default are in dynamic auto. Whereas for some switch models, by default, all the ports are in dynamic desirable. So let's take this one by one. Let's say this switch port is on a switch that all the switch ports are in dynamic desirable. Yep. So that's this port is dynamic desirable. You connect a PC to it. This port will send DTP frames to this PC. And the DTP frame is only saying this. I can be a trunk if you want to be a trunk. So just putting this in lay term, that's what the packet is saying. The packet is saying, or I'm saying packet again, layer 2 frame, layer 3 packet. The frame is saying, I can become a trunk if you want to be a trunk. But this PC goes and goes, hey, I have no idea what you're talking about, right? Because this DTP frame will go from this switch, will go to this PC, and this PC won't even reply. Because this PC has no understanding of what DTP is. So once this guy doesn't get any reply, it's going to be like, yeah, that means the guy on the other hand doesn't want to be a trunk. Therefore, I will be an access port. I'm not sure, is that clear? Is that clear, guys?
So, yeah.
So, I mean, we just follow little by little. Don't worry, we'll get to auto and what the difference between auto and desirable, what those differences are. We'll get to those. But just again, remember, DTP or switch port mode dynamic means I'm giving the switch the authority to decide whether a port will be access or trunk port. The way the switch will decide this is sending something called DTP frames. There are two modes of DTP. There's dynamic auto, there's dynamic desirable. If one end of the if a switch port is configured for dynamic desirable, it's going to tell the other one. So again, let me not confuse it. Let's go back to this one. Let's go slowly. So I'll come back to that. So that is for this one. So let's do the same for the switch. So we have a port on this switch connecting to a port on this switch. Now, this again, this switch is a switch model where all ports by default are in dynamic desirable mode. And also this switch, let's say it's also a switch model where all ports are in dynamic desirable mode. So what will happen is this one will send this DTP frame. And again, what does the DTP frame, what does it mean? Mark, what does the DTP frame mean? When this one sends a DTP frame?
I have no idea.
Again, remember, what did we mentioned it here. We said DTP frame means inside the frame, if you open it up, the information you find is this. I can be a trunk if you want to be a trunk.
Okay.
So that's the information. So this one, we send the DTP frame to this one and say, I can be a trunk if you want to be a trunk. This one too will also go, yeah, of course, let's copy this and then let's make multiple packets. Control C, Control V, yeah. So this one too will reply to him and say, I can also be a trunk if you also want to be a trunk. And because they are both communicating DTP to one another, this link will automatically become a trunk. I'm not sure, is that clear?
Yeah, so what happens maybe the PC is not able to reply in that manner, so it assumes that it
Exactly. It assumes you're not interested. It's like, you walk up to a lady. Not that I do this, I don't do this, I'm married. Probably a terrible example. My wife is not. You walk up to a lady in the bar, you're saying, hey, hello, how are you doing? And she's not replying. You're like, yeah, you're not interested.
Yeah, it doesn't do anything, so it doesn't.
Exactly.
Right.
So it goes and talks to the PC and says, hey, I desire to be a trunk, but the PC is like, nothing. And the guy's like, okay, I get it. You don't want to be a trunk. I'll be an access port. But then it goes to talk to a switch and it sends a DTP frame and says, I desire to be a trunk. And the switch goes, of course, me too. I desire to be a trunk also. It's like, whoa, we can both be trunks. And they just go, yeah, we'll be a trunk. So that's the basics. Again, this is not like the details. Yeah, exactly, Powell. It initiates negotiation. So it's a negotiation between the two. And we'll get into it in more details. But that's just like the basics of DTP. The basics of DTP is you're giving the switch using the command. Well, you don't have to use that command, but switch port mode dynamic. You're saying switch, I'm giving you the authority to decide whether this port will be an access or a trunk port. And then the way the switch will decide is using something called DTP frames. So if it's in dynamic desirable, yeah, which many switches are by default, all the ports on many switches are in dynamic desirable by default. So they will send DTP frames to one another. And based on that, if I send a DTP frame to you and then, you don't send anything to me, it means, hey, this guy doesn't want to be you don't want to be a trunk. I'll be an access port. But I send a DTP frame to you and you send it back to me. We negotiate and then we'll be a trunk. I'm not sure if that's clear, right? So let's move one step further. Yeah. So actually, let's go back to the switch that we'll have here. So let's go enable.
It's more like there's two elephants and they both have trunks, so they can both have trunks.
Exactly.
But the PC is in a giraffe, so he's like, I don't know what you're talking about.
Yeah, exactly.
I don't have a trunk, man.
Good explanation. I tell you, you should receive a lot of points for that explanation. So,
All right.
so going a step further to this one. So how do I determine which mode the switch port are on this switch? What command do I use to determine that? So I want to determine, is this switch, are all the ports, are they by default on dynamic desirable or by default? So Imran says show interface. So let's follow Imran's command, show interface fast 01. So where do I find out if it's um, dynamic desirable or dynamic auto here? Where do I find that out? I can't see anything here. Can you see anything that says dynamic desirable, dynamic auto, anything like that?
No, I don't see it.
Yeah, thanks very much, Mark. Don't forget that last part. Show interface switch port. Remember that command. Cisco likes bringing it out in a lot of exams, not in a lot of exams, in CCNA exam. Show interface switch port. So Imran is right. Imran just missed one part of it. You have to put show interface. No problems. You know, you're right, man. There's no need to say sorry. Show interface switch ports. And if I go enter, here we go. This shows lots of good information. Look at this. It says administrative mode. What this means is that this is the mode that this switch port is currently on. And this switch port is in which mode? Dynamic auto by default. We've not done anything. We've not configured anything. So actually, let's go back to the switch port interface fast01. Let's go conf3 um, interface fast01. Let's go switch port mode access. And then let's do show interface fast01 switch ports. Again, now look at this. Administrative mode is what? Access now, right? Well, let's change it a bit. Let's go switch port mode trunk. And let's see it again. Now, administrative mode is what? Trunk. Let's go again. Switch port mode, rather than access or trunk, let's say dynamic. Now, dynamic, I can set it to dynamic auto or dynamic desirable. By default, it was set to auto. So let's change this to desirable. And then let's do that again. And then administrative mode is dynamic desirable. So this leads us to a question now. We said DTP, there are two modes, dynamic auto or dynamic desirable. What's the difference between dynamic auto and dynamic desirable? What's the difference between them? What's the difference between them? Anyone want to go for it first?
I would assume desirable is asking if you want to be a trunk, whereas auto will just try to be a trunk without asking.
Let's see. Imran says auto is actively looking for um, auto is actively looking for what? Imran. What is auto trying to look for? Desire is passively. Imran says desire is passively looking for trunk. What do you think, Mark?
I don't know.
Yeah. So I mean, let's break. So Imran says it's passively looking for. Imran, I may be wrong. Correct me. I stand to be corrected. I stand to be corrected. Powell, correct me if I'm wrong. Desirable is active. So Imran, I think you switch them for one another. Desirable is active, whereby auto is passive. That's my understanding of it. So correct me if I'm wrong, Powell. All this. So desirable is active, auto is passive. What do we mean by that? Let's go back to this diagram. So remember that desirable will send out DTP frames, right? Right?
Yep.
Yeah. Whereas auto won't be. So desirable is like I'm actively trying to become a trunk. So it's sending out DTP frames all the time. Auto, on the other hand, will be like, I can be a trunk. So again, let's edit this a little bit. So DTP is I can be a trunk if you want to be a trunk. That's DTP. But let's now break it down a little. Desirable. I'm willing to become a trunk and I'm actively looking to become one. So
So
desirable, yeah, carry on.
so auto will participate, but it won't ask to be a
Exactly.
trunk.
Exactly. So auto, that's a really good. I mean, I couldn't have said it better. I was even thinking of saying it in a worse way than the way you said it in a more clever way. So auto is not desirable is asking. You know, auto is I'm not asking, but if you want to be a trunk, I'll be a trunk, but I won't ask you. You know, auto is like I won't go to be asking everyone, do you want to be a trunk? I'll just sit back. But if I receive a DTP frame, I'll reply and say, yeah, 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 I want to be a trunk. But desirable is, I'm looking for you. I'm like, I want to be a trunk and I'm going to be sending DTP frames to you. Is that clear?
Yep.
Imran, is that clear? So desirable is the active one. Auto is the passive one. So they're both looking to, they both have the same philosophy. I'll be a trunk if you want to be a trunk. No problem, Imran. I'll be a trunk if you want to be a trunk. Desirable is active, actively asking you if you want to be a trunk. Auto won't actively ask you, but if it gets any DTP frame from you, Auto will respond and say, yes, I want to be a trunk. So saying that, let's draw a table for ourselves and I'll let you fill this table all by yourself. So let's draw a table. So Mark, get ready. and
Oh
Carl,
no.
and
Here we
Carlos
go.
and Carlos, get ready. We've got a table here.
All right.
So let's draw a table. And the first place, let's put if the first
I
end
think I know where this is going.
if the
Me too.
first end is dynamic desirable, that's the first end. So let's go for the next one. So the next one is dynamic auto. So this guy here, dynamic auto. Then we have another one. That one is just simply we've gone and instead of saying switch port mode dynamic desirable or switch mode dynamic auto, we've gone and say switch port mode access. And then the last one, we've gone and say switch port mode trunk. So this is a trunk. And then let me edit the table a bit because I think I missed one field. So this is a trunk. So there's one field that I'm missing in the beginning. So let's add another one here. Uh, yeah, and let's say this one. Yeah, and then let's go dynamic desirable, dynamic auto, access, and static. So let's go here. Dynamic,
Just do
uh,
DD.
yeah, desirable, and this one is dynamic auto. Yeah, it's probably yeah, yeah, and then this one is access, and this one is trunk. So let's start with this first two, dynamic desirable. So if one end of the switch port is configured for dynamic desirable, so again, what is the underlying principle of DTP or switch port mode dynamic? What's the underlying principle? The switch will determine whether the port will be an access port, right? Or a trunk port by itself, right? That's the underlying principle. So the switch has this table to determine whether I will put this port as an access port or trunk port. So if one end of the port is dynamic desirable and the other end is dynamic desirable, will it become a trunk or will it be access port? Who wants to go first?
It, it'll be a trunk.
It'll be a trunk. Why?
Um, because one side will ask if it is, another one will say yes, I do.
Yeah, good one. So one side will send a DTP frame and says, hey, I can be a trunk if you want to be a trunk and I'm looking for you. And the other again will say, I'm also looking for you also. I'm willing to become a trunk also. So they're both sending DTP packets, they negotiate. Yeah, we'll go into more details later, but let's just do the foundation first, then we go into more details. So this would be a trunk. If one end is dynamic desirable and the other end is dynamic auto, will they be a trunk or will they be access? Mark, you want to
Trunk.
go for that? Trunk. Why? Why, Mark?
Because one's sending out, I can be a trunk, and the other one's looking for a trunk. So
So one is like, yeah, thank you, nice one, Mark. So one is like, yeah, I can be a trunk, but I'm not looking for you. But the other one is like, but I'm looking for you. So they will talk and they'll be a trunk. So this is where it's starting to get interesting. Now I'll explain something when we get on that trunk before we do it. So, but let's do access first. So the thing is, when you go under access, access is not sending out any information to be a trunk. Or let's answer. So do you think this
The
would be a trunk?
DTP package
Exactly.
or
So do you think this would be
frames.
yeah, exactly. Frames. That's right.
Sorry.
So do you think this would be a trunk? Dynamic desirable on one hand, access on one hand.
No,
Why? Why won't it be a trunk?
because it won't receive any DTP frames
Exactly.
back from the access
Access
side.
means, see, I'm not negotiating. Actually, if you go back to the switch port, you see the port says static access. It means I'm not looking to negotiate anything with you. It's going to have,
Right.
yeah. So if you,
Is it part of the frame just doesn't match what it's looking for? I mean, essentially,
no, so access is
or
like
does it not send that part of the frame?
access is like I'm not negotiating anything with anybody. I'll be an access no matter what you do.
Hmm. Yeah.
So if I go switch port mode access and let's go do and show interface switch ports, you see it says static access.
Hmm.
And then let's actually go back here and then let's go switch port mode access. Look at the description. It says set trunking mode to what? Access. Look at this word.
Unconditionally.
It means whether I receive a DTP frame or not, I don't care. I'll be an access port.
Right.
So do you think this will be access or do you think it will be trunk?
Access.
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 Yeah. And why is that? Again?
Because it says it'll be access unconditionally.
Yep.
So it overrides any other.
Okay. And then what about the last one, trunk? Will it be a trunk?
It'll be a trunk, but not because of the DTP frames.
Yeah. But here is one thing that I want to explain about trunk is that even though you go to your switch port and you type in switch port mode trunk, here's the bad thing about trunk is that trunk will still send out DTP frames. If you set it to be a trunk will still send out DTP frames.
Okay.
But here's the thing is that it's going to be, I will unconditionally be a trunk, but I'll still be sending out DTP frames. But here's the thing is that that's why they advise that because there's no point in wasting your time, when you manually set both of them to be trunk, just go in there and switch off. You have to go switch ports, no negotiate. If you don't use this command, let's say you have DTP enable. Okay, power says if on one side you have DTP disabled, mode trunk, yeah, and on the other side you have DTP enable dynamic auto, no negotiate, yeah. So what will happen if that's the case? What will happen? It means disable, yeah. So yeah, so power is right. We'll get to that also. But again, remember that trunking is sending out DTP packet unless you go and say no negotiate, which means I will act like access. I won't send any DTP packet. I'm not negotiating anything with anybody. I'm not sure. Is that clear a bit or is that clear?
Yeah.
Yeah. So this will be what? A trunk. So just within the next 5 minutes, so the time is 6:39 here now. So that will be 6:45. I'll come back. So if you calculate for yourself the orders, then we'll just come and we'll do a roll call of what you think the answer is.
Oh, this sounds like trouble.
So just calculate for yourself, know the answer, write them down. So in the next 5 minutes, we'll do a roll call of What does Mark think? What does Carlos think? What does David think? What does Imran think? And then we do a roll call and see whether we've truly understood the concept of why this one will be a trunk or why they won't be a trunk. So 5 minutes, we got 5 minutes for that. I'll be back in a minute.
So we're back to the multiple guess.
Well, you have a good track record, so.
I know, right?
Nice one, Mark. Anyone finished yet?
I finished.
Yep. Anyone else finished? Anyone else finished? Yeah, power's finished. Okay, got power and Mac. Oh, sorry. Let me bring out. Sorry for taking down the screen.
I think I got it in my head.
Yep. Okay. Good. So we got Carlos also. So we're waiting for Imran. Then we'll go and answer this one. Yep, Imran finished also. Nice one. Okay. So let's go for this one first. So what do you so let's do it this way. So you say what it is. So we go from let's go from left to right. So we got Carlos, Imran, Mark, Powell. Then my okay. Well, before Powell, I'll give my own answer. So let's go Carlos, Imran, Mark, David, Powell. So Carlos, what do you think? Trunk or access?
Trunk.
Trunk. Okay. Mark, what do you think?
For that one,
Yeah.
trunk.
Trunk. Yeah. Imran, what do you think? So let's see. Imran, trunk. Yep. And I also agree trunk and Powell as in trunk. Okay. Mark, you go for the second one first.
I would say access.
Access.
I don't. Yeah.
Good.
Because one has to be. Doesn't one have to be desirable to?
Good one.
No, that was a tricky one.
So What do you think? What do you think, Carlos?
I'd have to say access as well,
Mm?
but I don't know if you set something dynamic auto,
So,
what's the default state? Is the default state access or default state? I mean, it's not going to change. I mean, there's no DTP that's going to tell it. They're just both listening, so they
mhm.
should stay
Yeah, okay.
access.
My wife thinks it's access also. Imran, what does Imran think? Imran says no connectivity. That's a new one. Yeah, no connectivity, okay. Power, what do you think? I agree, it's access also. So what will happen is this. So Imran, let's help Imran with this. So what will happen is this. So let's get this switch, and let's get another switch. So let's get this port connected to. Actually, let's just. Mm, oh, sorry. Um, I just want to check whether, yeah, fastest and a 0 1. Okay, that's what we want. So let's go to both of them, fastest and a 0 1, and set them to dynamic auto. So let's go fastest and a 0 1 here. Enable conf because what will happen is this. Okay, so why do you say access, Mark and Carlos? Why do you say access?
Well, one has to be dynamic desirable instead of auto, because the desirable would send out the DTP, right?
Yeah,
Auto doesn't send anything out, so it's
yeah.
not going to negotiate with.
Yeah, because both of them will just go, yeah, I desire to be a trunk if I receive a DTP frame, but none of them is sending a DTP frame.
All
So
right.
let's go switch port mode dynamic auto and enter, and let's confirm it. Do show interface fast 0 1 switch ports. And that is in administrative mode. Let's expand this so we can see it. Dynamic auto, that's for switch 1. So let's go to switch 0 and do the same thing. Um, switch port mode dynamic auto, yep, and then let's do dynamic auto. Okay, so let's go here, let's unplug this, and then let's plug them back in. So fast Ethernet 0 1 to fast Ethernet 0 1, and let's see what will happen. So unfortunately, due to spanning tree. So what do you think is going on? Why this one is not yet green? Carlos, why is it not yet green? Why is it still amber?
They're both set to dynamic desire. I mean, dynamic auto.
Is
Is
that
that
why
what you said?
is that why they're both amber? Mark, what do you think?
They look red here, so they're shut down, right?
Is that what you think?
Well, they're both access ports, so I mean, what
Yeah.
happens when you connect two computers or well,
Ah, okay, sorry. I think it may be my own bad, sorry. I think I got the cable wrong. Sorry. I got the cable wrong, sorry.
mm,
That explains it.
There we go.
Yeah, but now they're both amber now. They are not green. Why are they both amber now? What's the
It
reason?
doesn't know what state to be put in.
What do you think, Carlos?
I don't know.
This was a topic that we discussed few weeks ago. Spanning tree. Exactly, power. That's it. Spanning tree. Remember, they all have to go through the modes of spanning tree. Exactly. Now they're green because they are going through listening, learning, forwarding, and they're going
you
through
wanted to
all the
answer
stuff.
in 30 seconds. Yeah.
Exactly. So so that's why. Okay. So let's go. Let's do switch port mode and let's see. Look at this. Operational mode, static access. So operational mode is what we've negotiated because one is like both of them are in dynamic auto, but eventually the operational mode is what? Access. Because they're both like I can be a trunk if I receive a DTP frame, but I'm not actively looking for it. And the other one is like so they're both keeping quiet. So nobody's sending out, "Hey, I want to be a trunk." So there will be what? There will be access ports. Is that clear? Is that clear, Himran? Is it clear, Imran?
Yeah.
Yep. Now, okay. So let's move to the next one. So that's access. So dynamic auto and access. What do we have? Who wants to go first? Maya, why you want to go first? Oh, Imran, sorry. Imran, you want to go first? Then we go Maya, then we go um, myself, then we go Carlos and Mark and Powell. So Imran says access. Okay. So Maya, what do you think? Imran says access. Maya, what do you think? Um, Maya thinks can't see your screen. Access. Okay. Sorry. So what do you think? Okay, I also think it's access. So what do you think, Carlos and Mac and Powell?
Access.
Access and Carlos, what do you think? Do you think it's access or trunk, Carlos? What do you think? Dynamic auto and access.
I'm saying access.
Access, yeah. Good one. And Imran, what's your reason for giving access? What's your reason for it? So let's see what Imran's reason is. Because of that in the static access config, exactly. So basically, no one is no one is sending out exactly, no one is sending out any DTP frames to say. So if you can understand the concept of, DTP frames and how all that works, you understand dynamic, you understand DTP clearly. It's a really simple thing to understand. But having said all this, there's no point going through like all the rest. What do you think this one will be? Dynamic auto and trunking. What do you think? Actually, let's just go through this one because this is related to the one
I
that
think it'll be trunking.
trunking. Yep, trunking. Yep. And what else? What do you think? So what's your reason, Carlos, actually?
Well, the trunking port's still gonna send DTP frames, so the auto side's still gonna hear it.
Yep. Okay. Yep. So the other side will become a trunk. Yep. Okay. But what if I do something like this? What if I say trunking, no negotiate?
Non-negotiate.
So what do you think will happen?
Won't negotiate a trunk.
Yeah. So which mode will
It'll
it be
stay
in?
access. Access.
No, again, remember. So this one will be dynamic auto. This one will be set to static trunk on one hand, but it's not going to be sending out DTP packet. So this one can't, if this one is access, that means you have an access port connected to a trunk port. You get the point? You can have access trunk. Imran
So it
says,
won't negotiate a trunk, but it'll still be broadcasting a trunk.
my one says access and trunk. Imran says trunk. Carla says access. Mark, what do you say? Do you think it's access trunk and dynamic?
Um, I refer my answer over to Carlos.
Good one. And Power says it will not negotiate, but if on one side it will be trunk, on other dynamic auto it will be trunk. Okay, so let's say I'm not sure if we can. Okay, actually let's see if we can do no negotiate on packet tracer. So let's go one hand. So let's go to interface file. Let's go switch port mode trunk. Yep. So this static trunk on switch 0. And the other hand is still set to dynamic auto, right? So if we do show internet, yeah, it's still sent to dynamic auto. So what we'll do is that because this one is still sending out DTP frames, right? Because it's trunk. But let's say switch port no negotiates. Yep. So we'll do that and then let's go Shots, no shots. And then let's see, to show interface. So this one says operational mode is trunk. So what does this one think its operational mode is? Okay, yeah, let's just remove the cable actually. Let's go remove the cable. Just plug the cable back. First Ethernet 01. First Ethernet 01. Now we have to wait for our wonderful, lovely spanning tree. But now, guys, all this being said about DTP, and all that. Now, this is really good for the exam. But in the real world, do you think you use DTP? So, Carlos, as a network admin, will you ever configure DTP on your network?
Not if I can't help it.
What's the reason? What's your reason?
Well, I mean, if someone just plugs into that port, another switch, then it becomes a trunk port, and they can start negotiating priority and set their own priority and become, a route, redirect all your traffic.
Yep, that's one reason. So let's go. So this dynamic auto trunk. So let's go to the other end, switch 0 that will set to static trunk. So can anyone explain this? So both of them are showing as trunk. I was thinking there won't be any communication because there won't be any DTP frames. So how come it's still trunk even though we've said no negotiate? My guess would be this is a packet tracer issue. Or does anyone have an explanation for that?
If we think about it, so the other side that you configured as trunk,
Yep.
though you told it not to negotiate, it
Yep.
should still be sending out BDPUs, right?
Yep.
And that will have multiple VLANs.
So you think it's BPDUs that is causing it?
Could it be? Then that would be a packet
Yeah, that's a
tracer
good
issue.
that's a good thought.
Because I was thinking about that would be now become a packet tracer issue, that maybe packet tracer saw
Issue, yeah.
BDPUs and then just automatically
Set it to be a trunk, yeah? It could
is
be. Yeah, that's true.
So my other question is, when it negotiates, what exactly is it sending?
DTP frames. So that's the one. So we mentioned that earlier. So
Exactly.
it's
So
sending
if we
this one.
block that,
Yeah.
so if it blocks that,
Yeah.
and we don't get that across,
Yeah.
but it still sees BDPUs,
Yeah.
maybe he could just assume that he had seen, maybe he missed it or something. But I think it's packet tracer really. It shouldn't really do anything. You should have one
that's what I'm
side trunk,
thinking.
one side access.
So let's see. Actually, we've got
Yeah.
so we've got something here. So non-negotiable.
Pavel, how's your confidence on packet tracer now?
So non-negotiate trunk and non-negotiate trunk and then dynamic auto. It says unexpected. So Cisco says unexpected results.
Exactly. So that's what I'm saying, that if the other side sees depending on how they write their code, the code could just act crazy.
Yeah. So you see, so switch port non-negotiate prevents the interface from generating DTP frames and all that. So let's see when they say unexpected result. What do they mean by unexpected results? Yeah, I mean I can't, but yeah, Cisco says unexpected result. So means we have no problems, Mark. Means we have unexpected results. But the thing is, it should not trunk. So it shouldn't go trunk. So that's probably packet. Yeah, that's packet. But you're right, my way. It could be that packet tracer, the way it's designed, maybe it's seeing BPDs. It's like, yeah, let's just set it to trunk. Okay, so is this Cisco statement? Yeah, it is. And that's actually from Cisco. Or let's see, actually, is that Cisco statement actually? Maybe not Cisco statement. Okay, this is made available for CCNA. Yeah, so this is from Cisco. Or is it? Maybe not. Oh,
I think it's a Cisco statement, really, because they tell you that they don't, depending on who you have at the other side. Because what if you're using non-Cisco switches, right? I think, wait, non-Cisco switches, they can't do desirable, right? Can they do desirable?
No, because DTP is Cisco proprietary.
It's Cisco proprietary, right? Cool. So it has to be a Cisco switch. I would say that's actually a Cisco statement that you don't know what could happen because depending on how they wrote the code,
Mm-hmm.
you may have different results.
Mm-hmm. Okay, let's see. It says predicts DTP behavior. That's activity 3.2.3.3. Yeah, okay. Maybe that will be in one of our labs that we'll do. But yeah, okay. So I hope that's clear, right? But well, Carlos, how's your confidence about figuring out DTP now? You're more confident with figuring out DTP?
Yeah, more than I was like
Yeah.
10 minutes ago.
Good. And Imran and Mark is gone. I know Mark will be back in a minute. And Imran also, what's your confidence in figuring out DTP? Yeah, good. Yeah. So that's like the main thing is that we understand like the basics of how DTP operates and all that. That being said, we won't really use it that much in a network because you normally in a typical network, you don't install switches every day. It's not as if you're plugging in switches that you want it to be dynamic. But typically, you plug in your switch at the beginning and they remain the same way for a long time. So normally you want them to be static, you want to set your trunk to be static. You don't want the switch to be making that decision of is it static, is it access. So normally you switch DTP off. But that's like the basics of DTP. So let's move to the next one. Carry on. You wanted to ask a question?
No, I was saying maybe you'd only use it like in home or your own personal small business where the hardware was locked up or something.
Mhm. I mean, I'm
Maybe.
not sure. Like, is there any reason? What do you think? What's your thought? What's your thoughts, guys? Is there any good reason why, in a network that you're managing, you will implement DTP? Any good reasons?
Maybe at the beginning if you're lazy, but even then you get unexpected results.
Yeah, I
You
mean,
know,
because the risk. Because if I think about the risk, like the risk of, okay, for number one, I want all my ports on the access layer. I want them to be access ports. I don't want any one of them to be accidentally configured for trunk, where somebody can, plug in a switch, access all my VLANs, and start capturing packets and stuff like that. So it could lead to like issues if somebody can just if the switch is automatically deciding if it's a trunk or an access port, there could be issues. Or what do you think? Does anyone else think? Or what's like the reason that have you ever? Is there any reason that you think that you
Well,
put this?
I mean, they come dynamic auto and dynamic desirable for a reason. It's for those who don't know how to use it.
Yep.
So at
Yeah.
this
Okay.
level,
Yeah. I see what you
you
mean.
probably don't,
Yeah.
but if you want to just plug and play and you have an
Yeah.
administrator who knows how to plug it in and
I see. Yeah. Yeah,
you know,
that's one good reason. Yeah. For people that you don't have a lot of Cisco administration, you send a switch to them so they can just plug it and it's just plug and play. Exactly, good one. And then if they come and plug another switch into it, it will automatically become a trunk. They don't have to be configuring anything. So yeah, that's a good reason
and then
for
their network crashes and they hire someone.
and then they look for someone that has Cisco skills. Okay, so the next 27 minutes, we'll try to do the other part of our discussion today. So, which is VTP? Again, this is like one of the this is like one of the poorly named issues again. VLAN Trunking Protocol. Somebody said he thinks that this should have been called VLAN Replication Protocol.
that would be a great name. Stop confusing.
Exactly.
Till today I mix up VTP and DTP all
Yep.
the time. I'm like, I don't exactly know which one I'm dealing with sometimes.
We
Exactly.
put another disclaimer on this one as well, like
Yeah.
you don't want to use this.
Yeah. So again, this is like badly named. This is not trunking anything. Again, yeah, it's not trunking anything. All that is simply doing it's replicating VLANs. It's not trunking any VLANs. It's just replicating VLANs from one switch to another. So, what's your understanding? I mean, just give me your general basic understanding of VTP. What does VTP do? How does it operate? How does it work?
So I would say like it would listen for similar VTP frames from any other broadcasters about VLANs it knows about.
Okay. Okay, listen to VTP frames re regarding VLANs that other switches know about. Any other thought about of VTPs? No problem.
Shares VLAN information between other VLANs.
Yep. Between other VLANs. You mean switches?
Yeah, that's
Yeah,
what it.
switches. Yeah. Any other thing like VTP. So, what about VTP versions? What are the versions that VTP? What are the versions of VTP that we have? Yep. What are the versions? I think I lost connectivity again. Did I lose connectivity? Ah, okay. No, no, not at all. So power says 1, 2, 3. Yeah. Okay. So good one. So we have version 1, version 2, version 3. Yep. And what's the difference between version 1, version 2, and version 3? See? Yep. And okay, yeah, why we're coming up with differences between version 1, version 2, and version 3? There's another thing that we'll discuss is VTP modes. So what are the different modes of VTP?
Server, client,
Yep.
and transparent.
Client, yep, and transparent. And what's like the different mode? What does it mean? Or what do they mean?
Server will update the other switches with VLAN information. Client will just receive the information. It can't make changes to the VLANs, I guess, the client.
Yep, you're correct.
And the I think transparent doesn't send any updates out, maybe, or
It doesn't react to it.
Yeah. Mine what says doesn't react to it, yeah.
It doesn't react to updates.
To update. Yep, anything else?
kind of like my kids when you try to tell them something.
So let's say
They don't react.
kind of like Max key.
So the server is the wife, the client's the husband.
Nice one. Okay, let's put that there.
Clean your room. Clean your room. Clean your room. We just continue playing their game.
I like all these explanations that are coming out. Like sometimes you
Yeah,
wonder.
you can't forget it this way. You can't forget it this way.
Client is the husband, so client can make any configuration changes. The
They have to listen
configuration
to the
comes from the
server.
wife.
But the kids don't listen to both.
I think we figured VTP out sincerely.
So we're gonna put a illustrated book together at the end of all this. Draw the
Client does,
picture for you.
wife does the configuration. The husband just takes the configuration, but the kid doesn't listen to both configuration.
I need to find myself a new server.
Oh God. Yeah. So we got we got VTP mode clear. So the other one will probably be this. So how does VTP work? So what are the
This
concepts?
stands for very very true parenting.
So, let's say VTP, VLAN Trunking Protocol, badly named, should be very. Is it very true parenting? Or VLAN replication protocol. I wish someone won't actually see our videos on the internet and actually and actually believe what we're saying and go to say this kind of thing in interview. And go,
They'll probably get hired for it.
and go, actually VTP should be very true parenting.
I will agree. If I'm interviewing someone and the person explains it that way, I'll hire him. Because he is like the person who understands it, really.
Yep.
Just taking apples to apples
Yep.
comparison.
Yeah, good one.
He'll be a good source of laughter for the team.
Yep, that's a good. How VTP operates. So how does VTP operate? So how does VTP operate? So anyone want to explain how VTP operates? So again, let's Control Z. Let's just get all the. Yep.
I do remember something about version number or
Good
revision
one.
number.
Good one. So how VTP operates. So let's go back there. Says we have to understand. To understand VTP, we have to understand this concept of revision number. Yep. So what does the revision number mean? What does it mean? What's the implication of the revision number?
The higher the number, the newest
A
change or
good
newest
one.
configuration.
Good one. So let me put that down. So let's put that down. So the highest revision number wins. Good one. So let's actually, I've not checked the chat window. Maybe other people are connecting. Carlos, oh, sorry, you're losing connectivity. Can you hear me now? Is it better now? Hello, is it better now? Can you hear me?
Yeah, I was losing it, but as soon as you started talking about how it operates, I got connectivity back. So
Sorry.
Yeah, I saw two Carloses at the time, and one of them disappeared.
He was in transparent mode.
I was not
Kids.
listening. Yeah, yeah. So to understand VTP, you have to understand the concept of the VTP advertisement and the revision number. So let's start from the beginning. So you go to this switch, and as a network administrator, you want to create VLANs on this switch. So you go and say, configuration terminal VLAN 10, 20, 30, 40. You just created 4 VLANs on this switch. So when you create these VLANs, the information is stored on a file called VLAN.dat, which is stored in the flash memory. So that contains the information of all the VLANs on the switches. So when you do that, the next thing that happens is the revision number, the VLAN, let's put it this way, the VLAN revision number is incremented by 1. So let's go back to the 2 switches that we got here. So we got 2 switches here. So if we go show VTP status, here we go. So we have configuration revision number, this one. It currently is 0. So because VTP will come to the version and the mode. So if I go conft VLAN 10 enter, do show VTP status. Now we see configuration revision number as incremented by 1. So any change that I made to VLAN.dat increases the configuration revision by 1. So if I come here and I say, okay, I've changed my mind, I don't need VLAN 10, I go no VLAN 10, and then show VTP status again, it incremented it. So whether I had a VLAN, remove a VLAN, modify a VLAN, it increments the configuration revision number by 1. Again, if I go VLAN and 20, name management, and then show VTP status again, now it's incremented it by 2. So the importance of this is this. The highest configuration number wins. So in VTP, let's just use an illustration. Let's say they're both talking to one another, they're both accepting VTP advertisement. So let's say the configuration revision number of this one is 10, configuration revision number of this one is 15, configuration revision number of this one is 21. What this one would do is this one will send out an advertisement. Send out an advertisement on its trunk links, and this guy will receive it. And the advertisement will contain the VLAN information, including the revision number. And this guy goes, okay, you've got a higher configuration revision number than me. So what I would do is I'll flush out my VLAN.dat file and just replicate it with the one that you're sending to me. So that's like the whole concept behind how VTP operates. It operates with the concept of advertisement and revision number. So VLAN advertisement goes across trunk links, and then revision number, so it applies it based on like the highest revision number wins. So we mentioned the different modes. Let's start with the modes first. So there's server mode, which we've said correctly. So server mode simply means I can go on this switch and make VLAN changes on the switch, and then the switch will send out VLAN advertisements to other switches. So I can make VLAN changes, and switch will send VLAN advertisement to other switches also. So if I go to, we can go to, say client. Client means, like Mark said, can't make VLAN changes. And then the thing about client is it will also send adverts. So switch will send adverts to other switches. So it will still send advertisements to other switches, only that you cannot make any change on it. But the other thing about the other important point about server and clients is this. If you go on a client switch, can you find any VLAN.dat file? So let's say we've set this switch to client, this one to server. So if I go on this switch and I go show flash, I'll see a file called VLAN.dat. If I do a show flash on this, would there be any file called VLAN.dat on this switch? What do you think? Would there be VLAN.dat on it?
I would think it would still have one, right?
What do you think? Noah says yes. What do you think? Mark, what do you think? Do we? And Imran says yes. Noah said yes.
Yeah, I think so.
If this one is set to client, it's a client switch. It's in client mode. Will there still be a VLAN.dat file? Actually, I think the answer is no. It doesn't have a VLAN.dat file.
That's what I said.
You're right, man. It doesn't have a VLAN.dat file. It loads its VLAN information directly into RAM. There's nothing stored in the flash. So actually, let's see if Packet Tracer is correct. So whether Packet Tracer says it has it or not, whether Packet Tracer says it has it or not, because I was still reading this one last week. So it actually doesn't have a VLAN.dat file. So let's go exit.
If you configured it manually, it would have one, but right?
Because on the client, once you make it a client, it means you can't make any VLAN configuration. So let's go VTP domain Cisco, and then let's call this again. Let me just ask some questions as we're going on. I've set this to VTP domain Cisco, right? That's on switch 0. Let's go to switch 1. Enable conft hostname switch 1. So let's go do show VTP status. So you can see that this one is set to, oh, okay, yeah. It automatically sets. Now, I've not configured this one to say the domain name is Cisco, but it automatically set itself to Cisco. Why is that? Why is that? Because I've not set this one to Cisco at all. I changed it on one.
The other one has a higher revision, so it's sending out That's a server, and
But what I
it's
mean is that because VTP, we're taught that they have to be in the same domain at first. Yeah, you're right, Powell. We are taught that they have to be in the same domain, right? Before they start before they start receiving advertisement from one another. So if you have a switch in VTP domain test and another switch in VTP domain Cisco, they won't exchange advertisement and speak to one another. They have to be in the same domain name. But now I went to this one and set a domain of Cisco, and the other one instantly changed its name to Cisco. Powell is right because it is in a no because when you first set up a switch, that is when it is most vulnerable because it's in a domain, it's with a domain name called null, which means if it receives any advertisement, it will pick it up. So that is like something to be really careful of. If it's in a null, so let's just reload this switch. Let's do exit. So let's not save anything. Let's just go reload. Let's not save anything. So we're not going to save do copy on that. So it should come back with nothing on it. And let's do this one also. If I do end reload confirm, because actually I think this one will have picked it up also. Enable show VTP status. Yeah, it's picked it up also. You can you see where an issue can start coming in? Enable reload. You have to because they're just updating each other with the name. So let's go enable show VTP status. Yeah, let's just delete both of them. Because otherwise you will just keep going round and round and they just yes. So let's have a new switch and another new switch here. And let's have them connect to one another. Okay.
Yeah, Powell is right
Yeah.
because instead to do reload, it stores it onto the VLAN dat file.
Ah, that's right. That's right. That's absolutely right.
Remember,
I didn't even think
remember I
about
said I
that.
had a problem with that to myself that I
Yeah.
just did that and I was like, what is happening?
Yeah,
What is happening? Why?
that's absolutely right, Paul. I didn't even think about that. So that's absolutely right. So show VTP
I almost went
status.
crazy.
Yeah. So look at that's right. Absolutely right, Paul. So look at this VLAN domain name. No. So when it's in this state, the switch is vulnerable because if it receives a VLAN advertisement, it will start applying it. So we have to be careful of this domain name. Yeah, because that's really, really important. If it's a null, even though you've not come and say, I'm setting you to VTP domain name Cisco, you've just left it in the null mode, it will apply the changes that you've made on the other one. So that's something to note. So let's do sorry, and it will start the silly domain name lookup stuff. Let's bring this one up and let's quickly see the one that we're talking about. So if you do enable conft, let's do VTP mode and client. And then, of course, we can't create any VLAN information. So if we go VLAN 10 now, it says VTP is in VLAN mode. We can't configure anything. But again, if you go VTP domain Cisco, change the VTP name from null to Cisco. Okay, so we're in Cisco mode now. So do show VTP status. So, yep. Then let's go on this guy and set him to. He's still looking up domain name. Come on. Come on. Go away, go away. So what we'll do is let's go on this one. Enable conft VTP mode server. Yep, it's in server mode by default. So let's go VTP domain Cisco. Yep, so this is now in Cisco mode. So let's do VLAN 10 and then let's end this. So show flash. We have VLAN.dat file here. So do show flash. So actually, like it's saying it's got VLAN.dat here. But if anything that I read in Cisco textbook is to go by, it doesn't have VLAN.dat on client mode switches. Client mode switches load the if I'm right, you need to confirm, but I absolutely read
Wait,
this.
I have a question.
Yeah,
So before you configure it as a client, isn't it by default first a server?
yeah, it's by default the
All
server.
right. So then, because it's a server, it
Mm.
should have a VLAN.dat
So maybe,
regardless
so maybe
first.
that could be it. So because what I read was this is that if you configure in client mode, it doesn't now I'm not sure if it's that it has a VLAN.dat file, but it doesn't load information from the VLAN.dat file.
Okay, yeah. So what we
But
could do is we could delete the
delete that,
VLAN.dat
yeah,
file
yeah. So
and
let's
then
do,
save and see what happens.
yeah. So let's do right. So again, I won't trust packet tracer that much, but let's see. Let's do exit. So let's do
I thought it will have a copy there that could be updated, but it can't update it itself.
yeah. So yeah. So but the thing I read is that it doesn't even have VLAN.dat. It loads it directly from the server. So that if it doesn't have any server to get information from, it actually doesn't have any VLAN configuration on it. That was what I read last week in a Cisco textbook.
Yeah, but what you read is correct, but
Yeah.
you have to remember that if it was a server first, then it should have a VLAN.dat. So when you now change it to client, does it go ahead and automatically delete this
Delete that,
VLAN.dat
yeah.
file? I don't think it does that. I think it just doesn't use it.
Yeah. So let's reload this one. So Power says in server mode, VLAN.dat in RAM is the same as in Flash. In client mode, VLAN.dat is valid only exactly. So it loads it in RAM. In Flash could be VLAN.dat, but it is not used. Okay, yeah. So that was
Yeah.
maybe that explains. So if I
What
do,
happens when you put it back in server mode? I mean, it's going to use this last VLAN.dat.
yeah. So you see, it's
Yep.
got no VLAN.dat, but let's do
Now,
show VLAN. But let's go to the other one and let's update it. Let's go to let's go conft VLAN 10. Again, if we just do show VTP status, it will remove the domain name. I think this is like packet tracer issue. Because it even removed the domain name that we configured. It set it back to null. Yeah, so actually, I think Power's explanation explains what the thing I was reading last week, where it says in server mode, VLAN.dat file is in RAM, and it's the same in Flash. It's but in client mode, it doesn't even look at for its VLAN configuration when you're loading it up. It doesn't load anything from VLAN.dat in Flash. It's looking for a server to load its VLAN information from. And if it doesn't find any server, no VLAN configuration will apply on the switch.
I don't know if that's right.
Yeah, that was what I was reading last week.
yeah, that sounds correct to me.
Yep.
Remember, server sends out VLAN information on for the VTPs.
Yep.
Client accepts it. So if my switch is configured as a client, it will expect that he should get an update from his server.
Mm-hmm.
But didn't you just say his server is now null after deleting the .dat?
Yeah,
the domain is null. Domain name is null.
Mm-hmm.
So, but that we said is a packet tracer issue. So let's say the server, let's say we enable or configure a domain name on that server. The server is still going to send out information. The reason why the client is even null is because the server was null. The domain name on the server was null, and the server sent out information, and whatever was configured on the client before that was Cisco went back to null, just because the server said it's null.
Yeah.
You understand? So if you configure domain name on the server, anything you do on the server changes what you have on the client, and the client will always ignore its local VLAN.dat file, even if you put a file, even if you copy a file there, it will ignore it because it's in client mode.
Yeah, that's the question the question that I'm asking. That's the same question that this guy is asking here. So basically, the guy is like, from everything I've read, a switch running in VTP client mode does not save its VLAN info anywhere. So it's not saved anywhere, just loaded directly into RAM from the server. So when I was setting up VTP in my lab, I noticed that when I configured one of the switches to client mode, it created a VLAN.dat file. Even after I reboot the studio. How would they do this when it's switching VTP client mode? I think
He's
maybe
wrong. It wasn't created when it was in client mode. It was created when it was in
server
server.
mode. Yeah.
He just didn't know it. He didn't notice.
Yeah.
Ah, you see what that guy said earlier. That VLAN.that file stays there despite the fact you delete all the files.
Yeah.
That's actually what messed me up when I was my bad experience with the switches that made me look like a fool.
Mm-hmm. Yeah. Let's see. I also confirmed that the VLAN.dat file does stay in Flash for switches in client mode. So let's see, because I mean, last week I was reading one of Cisco's textbooks, and yeah. So for the client, does it mention, where does it mention client? Let's just look for client. I'm sure it's gonna, it doesn't have that much. Um, the VLAN information, the VT information are not displayed in show running config when the switch is in the VLAN server. Yeah. A Cisco Catalyst 6500 switches in VTP client mode. In order to reset the VLAN information, you have to remove the VLAN.dat file and reload the switch. Mm,
This is basically if you want to reset it.
return the switch.
Which is what we did. We deleted it. It says empty.
Mm, yeah, let's see if I find if there's anything else more.
No VLAN.dat file in VTP client mode will switch boot OK.
Ah, which one is that? I clicked that. Okay. Mm.
I actually prefer these guys because these guys are professionals.
My question is if I schedule a reload of the router tonight. Mm. I'm not sure this one. And it's about VTP. If the domain name is left blank, it will configure itself with the domain name length from the. Mm, okay, yeah. I mean, I'm not sure if you can. I'll try to look for like if there's a Cisco link from the test from the textbook I was reading last week, and then maybe post in the community page. And then your own findings also, you can post it in the community page. But that's one of the reasons why we have discussions like this. But I mean, you confirmed that one. But I'm sure that something similar to what Powell said, if I'm not misunderstanding it, which corresponds to what Maiwa said also, that was read. What that was what I read in the textbook I was. That was what I read in textbook I was using last week. Okay, so let's move. So I'm not sure, Carlos, was that helpful or is that helpful? So you have to do some research on that.
Yeah, I'm so
Yeah,
doubtful.
yeah. So you have to do some research on that. But I read something similar to what my one and Powell said. I read that in a textbook. Clearly read it in textbook last week that it could be that maybe it exists but it's not used at all. But the VLAN.dat file has no on the client mode. It has no impact on the VLAN configuration on the switch. So the only thing that has an impact is what's loaded into RAM from the server. But again, we need to research that. I'll look for links on that if I find any. But yeah, okay. So we have server mode, we have client mode, and then we have transparent mode. So what's the one with transparent mode? Transparent mode means you can make VLAN changes. Like we said earlier, it will ignore anything. You can make VLAN changes. It will ignore any advertisement. So in other words, this guy doesn't want to participate in VTP at all. So ignores advertisement, and it will. Okay, so here's the thing. Transparent mode, will he send out adverts or not?
I don't think so.
Yeah. What do you think?
No.
Yeah, no. Okay, what do you think, Carlos and everyone else? Will he send out?
No.
No. Okay. Um, what if it receive an advertisement from another switch? Will it forward it?
Yeah.
So let us say
It's
that.
like it's not there, so it just goes right through.
When your kids stand in front of the TV and ask, "Was your father made a glass maker?" You say yes, and they can see through.
Yeah, so you're right that in terms of it will not send, but it's going to forward. If it receives VLAN advertisement, it will forward it. So if a switch, maybe a client switch or another server switch, send VLAN advertisement to it, it will be like, yeah, I won't apply this, I won't react to it like Maya said, but I will just forward it to other switches out my trunk port. But here's the thing, does it forward it? If I have the switch in VTP version 1, will it forward um, VTP advertisement? Will it?
Yeah, I've forgotten about the versions. I'll have to be reminded about that.
Iman
I
said
don't know.
yes. What do you think? What do you think, Mark? Do you think? Yeah, no problem, my wife. What do you think, Mark? Do you think it will forward VLAN if you yeah version 1? If you have version 1 on all switches, yes. So will it forward with VTP advertisement be forwarded on a transparent switch? So actually it won't, because one of the functionalities that VLAN VTP version 2 brought is that if you put a switch in transparent mode, it will forward VTP advertisement. So that's a functionality that was added in version 2, so not in version 1. So version 1 won't, version 2 will forward advertisement. So that's for that. So what else? So we have the modes, we have the server mode, the client mode, the transparent mode. We have the advertisement and the revision numbers. And then we have the versions. We have version 1, version 2, version 3. I mean, I'm even reading like the CCNP switchbook. I didn't really find version 3 in there.
I just want to read here. It says
Yeah,
version dependent transparent mode.
yeah. Which one is
I
that?
know it says it under version 2, but it's like in VTP version 1, a VTP transparent switch inspects the VTP message for the domain name
Hmm.
and version and forwards a message only if the version and the domain name match. So if it matches in version 1, it'll do it,
Is that in
but they have
version
to
1?
match. Yeah, I'll send the link.
Let's see.
It has to match. I
Mm,
think version 2 is less strict.
let's see. Let's click on that link. So Cisco VTP. So version.
If you go down to version 2
Yeah,
and then version dependent transparent mode,
yeah. Forward to message only if the version and domain name match. Yeah, because VTP version 2 supports only one domain. Yeah. Yeah. Okay. So actually, like this like let's see. In VTP version 1, the VTP transparent switch inspects VTP messages for the domain and version. I mean, I'm under the impression that VTP only function if you have the same versions. Well, not all, not in some situation, but it functions if you have the same domain name configured on the switches anyway.
right? But I guess if you have VTP mode version 1 and you have transparent on,
Hmm.
the transparent has to also have the same revision number or
Because
same version number, right?
yeah,
Are they talking about version of VTP or revision of VTP?
the version. So the VTP version. So it says
Okay.
VTP version 2 supports these features that are not supported in version 1. Token ring. Thanks very much. That's really helpful. We need
Okay, so
token.
you have to have VTP 1 and VTP 1
Yeah, we
plus a
need.
domain for it to actually be transparent. You could do it, but you have to have
Say
it all
VTP
matching.
version 1, a VTP transfer switch inspects VTP messages for the domain name and version and forward the message only if the version and domain name match. Support only one domain. First VTP messages in transparent mode without expecting the version and domain. Oh, okay, I see. Yeah. So for VTP okay, I see what you mean. That if it's in version 1, it can forward, but if it's in only if the domain name and the version matches. But then the other question would be, if you have a switch in transparent mode, it, it has its own VLAN configuration. So why would you put it in the same domain as the other switches? Normally you want it like something independent. So that
Yeah,
means
it's
you
just,
still have to go on that transparent switch and configure a domain name that matches, the server and the clients that you want it to forward to. So only if it matches will it forward. So yeah, so
Yeah,
yeah,
that's good information. That's
yeah,
good information,
yeah,
really.
it is. Yes. But then in version 2, it forwards without inspecting the version or domain or anything. So yeah, good one, good one. And then version 3, I've absolutely, even in like the CCNP switch book, I didn't find anything on version 3. So, so I'm not sure if it's CCIE level. I'm not sure. I have no idea. The version 3. Then the one about VLAN pruning. Because now if you've got VLAN 10 here, you got VLAN 20, you got VLAN 30, and then this one you've got VLAN 15. It doesn't have VLAN 10 and VLAN 20 on this, you know. So will you want um, packets that are meant for VLAN 10 and VLAN 20 to still be forwarded to this guy? So that's where VLAN pruning comes in. So VLAN pruning doesn't delete the VLAN from the database of the switch. All it does is it uses VTP to stop the traffic from traveling across the link. So it's not as if it goes on this switch and deletes and says, oh, because you don't have anything configured for VLAN 20, I'll remove VLAN 20 from you. Let's say this is a server. Let's say it's my client, and I remove VLAN 20 from you. So it won't remove it from the switch. All it's gonna do is it's gonna use VTP to block the traffic from traveling down this path, but it's not gonna remove it from the switch if the switch is server. Yeah. Then the other one would be, shutting down VLANs and suspending VLANs. So because you can shut down a VLAN, um, and I'm not sure, is it shut down or suspend? One of them is advertised. If I go, for example, let's create a VLAN on this. Enable conft VLAN 20, and if I do, um, will it allow me to do this? Yeah, sorry, this packet tracer stuff. But yeah, so there are two things. So let's say, for example, you want to stop traffic. You may need this maybe for security reason, maybe if a VLAN has been compromised. You want to shut down traffic from going or coming into a VLAN. There are two commands that you can use. You can either suspend, so you can go under the VLAN and suspend it, or you can either shut down the VLAN. So any which mode, it's gonna stop the VLAN. It's going to stop traffic in or from the VLAN. I think suspend or I think shut down, one of them is advertised, one of them is not advertised by VTP. So that means if I go on a switch, let's say this is client, this server, and this one is also server. If I shut down on this one, it won't matter what on this one. I mean, it won't have any effect. But if I suspend on this one, VTP will advertise it and it will suspend it on this one also. Does anyone know which one is advertised, which one is not advertised in between suspend and shutdown? VLAN suspend VTP. So shutdown versus suspended VLAN. So let's see. So you just remember that one of them will be advertised via VTP, while the other one is only locally. Okay, so a shutdown for the VLAN means both locally and internally shutted down. Um,
remember, those are questions right there.
okay, this is a bit of information about suspended VLAN. Let's see. Okay, yeah. So the suspended state is propagated through VTP domain, but the shutdown does not. So they accomplish the same goals in terms of data won't go in or out of that VLAN, but suspended. So if you go, you can basically go on one of the server switches and go, suspend, go under the VLAN and suspend it. That will travel to every other switch and it's going to shut down that VLAN. No traffic will go in and out. But if you do shutdown, it only does it locally and it won't affect the VLAN on the other switch. So Power says only version 3 you can use all 12 bits in VLAN ID. I see. Nice one. Power, if you can send the link for that one also, so we can have a look through that. So okay, so I hope that that's like helpful, right? So today we've done VTP, we've done DTP, and we have an understanding of what both protocols or what they accomplish and how they accomplish what they accomplish. So what are we doing next week? Let's see.
Can you repeat it all?
Sorry, I said so today.
Yeah, DTP, VTP. Good night, class.
So we've we've done so today we've explained we've discussed DTP, Dynamic Trunking Protocol, and VTP, VLAN Trunking Protocol in today's Hangout.
Man, they
So
should change that name.
because it's not trunking anything, but yeah, who knows? But let's see what we're going
It's
to be doing.
confusing.
It is. I agree.
It could be very tired parents.
Let's go
Don't
to.
trust your parents.
By the way,
Yeah.
Mark, the question no, for Mark, the question on that switch port mode access.
Mhm.
The first question they will ping. The second question they would not ping because the first question they will ping because it's I don't know if you can. Well, when you're done your stuff, maybe I'll present my screen.
Yeah, sorry, carry on. I finished now. So basically,
Oh,
what
okay.
I wanted to say is that next week we're discussing switch security. So that's what we're discussing next week. And so today we're done with VTP and DTP. We can do the labs. Next week, switch security. Okay, yeah, carry on, Maiwa.
Yeah. So if you can go to your wait. Let's use your presentation. You
Okay.
go to the go to. I have two screens, so you might mess it up.
Yeah.
So if you go to the group,
To the group, yeah. So let's go
group
to the
something. You're in
group.
events right now.
Okay, yeah. So if I go to the group, yeah.
Yes.
Yep.
All right, so scroll down. You'll see the question I asked in regards the one with the diagram with PC1, PC2, and switch 0, switch 1.
This one.
Yeah, that one.
Yeah.
Exactly.
Yeah.
So for first question, the PCs should be able to ping.
Mhm.
And the reason is because, like, think about it. If PC0 wants to send a ping to 10.0.0.0.2, because they're in the same subnet,
Mhm.
right? It's going to believe that he should be able to contact it directly.
Mhm.
But problem is, it doesn't know the MAC address of PC1, right?
Mhm.
So it's going to send out what? An app frame.
Mhm.
And the app frame has a destination MAC address of a broadcast, which is FFFFF.
Yeah.
Right. All right. So you don't want that on your grade, but that's what it sends an app.
Mhm.
So it sends that out. Now that app frame would have no VLAN information on it,
Mhm.
right?
Yeah. Go on tag.
So I want to make sure it's Mark. Mark, you're getting that right?
Yeah, I didn't see I missed one of the questions there.
All right. Okay. So
Let me expand it. Shall I?
I see
all
what you're
right.
saying
You can click on the image
Okay.
itself.
No, actually, yeah.
Just click on the image, so that'll
Yeah.
make
Okay.
it
Yeah.
bigger.
Better.
All right, cool. So the PC0, right, wants to ping PC1. It's going to send out a broadcast. It's going to send out an app frame. All app frames, when they're advertising, have a broadcast MAC address, which is FFFFF. That means send it to everybody, right? So everybody on your domain or on your subnet.
Mhm.
So what happens is that frame has no VLAN information on it.
Yeah.
Because except the special PC NIC card that can do VLAN,
Mhm.
most PCs don't understand what VLAN is. They don't bother.
Mhm.
All right. So we send that frame into switch 0
Mhm.
and switch 0 now on port F024.
Mhm.
Now port F024 is configured as switch port mode access, right?
Yeah.
All right. So what that means is that it's going to accept all packets on that port. He expects them to have no VLAN information,
Yeah.
right?
Yeah.
And when they come in, it's going to assign when it wants to send it out.
Mhm.
It will recognize that frame
Yeah.
came in on VLAN 20
Mhm.
or VLAN 10. Sorry, in this case it's VLAN 10. Sorry, my bad. On VLAN 10. So now what will happen to the switch? The switch sees that it's a broadcast app and it sees that the destination MAC address is FFFFFF, and does not have an idea of, it knows it's coming from VLAN, right? But doesn't know, he knows by that broadcast destination MAC address that he needs to send it to everybody, right? So it's going to send it to everybody on the same VLAN 20. No, sorry, I keep saying to VLAN 20 on the same VLAN 10 because that's what switches do. Switches, if they don't know the destination MAC address, if they don't have an entry of that in their forwarding database table, would send packet and frames out on all ports for that VLAN. Right? Okay. So and if it's a broadcast, it will do the same thing. So that's a switch behavior. It will, if it doesn't know the destination MAC address, it will send it out on all ports for all ports linked to that VLAN. And if it's a broadcast frame, if its the destination is a broadcast frame, then it will do the same thing. It will send it out on all VLANs. No, not all VLANs, on all ports on that VLAN. So it's going to search its own. It's going to look at itself and say, which ports do I have that? Which ports are configured for VLAN 10 on switch S0? Well, it knows that F024, which it came from, is 10, but it won't send it back out that way. It knows F01 is 10, so it's going to forward it out that way. Now, this is where it becomes a problem. F01 on switch 0 is also configured as switch port mode access. Now, the behavior of switch port mode access is when we receive frames, we can tag it, but when we are sending frames out of our ports, we untag it, remove all the VLAN information, we strip it and just send the frame empty like that, without any VLAN information. So that's what's going to happen here. It's going to send out that app request out F01, but it's going to strip out the VLAN information saying it's from VLAN 10. Right? So that means that it's going to go from F01 on switch 0 all the way into switch 1 on F02. You get that? And switch 1 is going to accept that frame and look at it and say, oh, there's no VLAN information from this. This must come from a directly connected PC. Right? And then it comes into switch 1, and switch 1 looks at the destination MAC address and says, the MAC address is broadcast, it's FFFFF. All right, cool. So I'm going to have to send this out on all ports or linked to on all ports linked to the same VLAN that I got the frame and that I received the frame. So it looks at the port where you received the frame, F02. That is what VLAN 20. All right, cool. So it's going to have to send out that frame out of all ports that are configured for VLAN 20. And on switch 1, what are the two ports configured for VLAN 20? F02, F024. Well, you can't send it out back F02 because you received it from F02. So it's going to send out F024. But again, take note, as I said, both switch F024 and switch both F024 and F02 on switch 1 are configured as VLAN as a switch port access mode, right?
Yeah, that's the reason why to work. Yeah,
All
because
right.
both of them are in access. Yeah.
It's cool. So it's going to send it out outside that. It's going to send that frame out of F024, but it's going to remove that VLAN information again. And the PC one's going to get it, and PC one's going to just feel like, wow, this PC is right in front of me. And it's going to look at it's a broadcast frame. It's going to strip. It's going to open it because the broadcast frame. Look at it and say, oh, it's an app request looking for my IP address. So it's going to send out a frame, a app response saying, okay, oh, what's that, private? Oh, yeah. But that's why I banned you from answering it, Pavel. I was like, Pavel shouldn't answer. You already answered it before.
I think Pavel should be studying for CCNA now. I'm not sure.
So PC1 is going to get it. It's going to open it. It's going to realize that it's an app request saying, who is 10.0.0.2? Tell me your MAC address. So PC1 is going to respond with an app response, but it's going to use a unicast app wrap. It's not a unicast destination, or the destination MAC address of its app response will be the MAC address of the PC0. because all that while the frame was being sent, the destination MAC address is broadcast, but the source MAC is that of PC0, right?
Yeah.
So that's how he knows, because even the app request says tell this, tell 10.0.0.1. So it's going to know that 10.0.1 is, it's going to match the 10.0.1 IP address and the MAC address on its own app table. That's all. If you now type show app on PC1, you should see that I am 10.0.1 10.0.0.1 and the MAC address of PC0. All right, so PC1 is going to send that information. Say it's going to send the app frame, app response frame going there, and then it's going to enter F024, right?
Yeah.
As switch port mode, switch port access mode, right?
Yeah.
So switch 1 is going to see it as, okay, I'm receiving a frame, has no VLAN information, but it's coming in from a switch port access mode port, right? So I expect it's a PC. All right, so I'll have to manage the VLAN. So what VLAN did it come on again? It came in on VLAN 20. All right, cool. It came in on VLAN 20. The destination, by this time he knows the destination MAC address, right? Because he saw it when he received the first frame, right? He updated its sporting database table, right? But let's even say it doesn't have. Let's say for some reason you cleared the switch's forwarding database table. It will still do the same thing. It will still do a lookup on its forwarding database table. If it sees nothing, it's going to send it out on all ports linked to that VLAN, right? All right, cool. So regardless whether it has it on its entry table, on its forwarding database table or not, it's going to send out a frame. That is going to send out that frame outside F02, because F02 is VLAN 20. But because the switch port mode access is going to strip the VLAN information on it again, it won't send the frame out with VLAN 20 information. It will just send it out straight like that. That goes into S01 on F01, right? Okay. S01 is going to look at it as in, oh, I received the frame. I see that the source is the source MAC address is PC1. He's going to learn that, he's going to update that on his sporting database table, and realize that, okay, well, I shouldn't drop this packet because my port is in switch port access mode, which means I should be receiving frames without tags, right? VLAN tags on it. So he gets that information, gets that frame, and says, what should I do with it? I should forward it out. By this time, he should have the MAC address there, right, on his own forwarding, and we should forward it out on F024. But let's say that's not the case, right? If that's not the case, it will still forward it out on all ports regardless. So that means that regardless of whatever happens, switch 0 must send out that frame out of 4024. So 4024 is, remember, switch port mode access. So it's going to send out that frame with no VLAN. And PC0 is going to get the app response saying PC1's MAC address is this, right? Okay, so PC1 will now send out a ping, an ICMP packet encapsulated. But guess what? Though it's sending ping, we're still dealing with layer 2, right? So the same process that we had in app is not going to happen again with that. So it just keeps going up. That way, it's going to be able to work, because the issue is that when we're sending out frames, which is why I said, which is the whole essence of the question is for you to understand that
tagging and how it works.
Access, exactly. Switch port mode access does not send out frames and does not send out frames with VLAN information. And it receives frame with without VLAN information. However, if it had VLAN information on it, it would block it if the VLAN doesn't match. Right? So that's the thing. But for now, because when you connect two ports that switch port mode access on two switches, it's going to work. The ping would work. Now, the second question said, if I change the IP address of PC2 to 10.2.2.2.24, what would happen? Well, PC1 realizes that 10.2.2.2.24 is not in its own subnet. So he needs to send it out a gateway, right?
Yeah.
But there's no gateway configured for this.
Yeah.
So he's just going to drop the packet. He's
Yeah.
not going to bother. He doesn't
Yeah.
know doesn't know what to do with it. So
Yeah.
just going to let it go.
Yeah, that's fine. So yeah, in other words, like what my way saying is that if you got a switch, so it's one of the things that about you get it's one of the things that one will get to later. You get a switch, you have switch ports. So you have a port on this switch. So actually, let's make this if making the switch port bigger, you've got queues on these switch ports. You've got little queues. You've got the ingress queue and the egress queue, which means if a PC is connected to this port, you have a PC connected to this port. So done in 2 minutes. So if I have a PC just connected to this port, if this PC wants to send something, so this will go out in its egress queue. You know, whatever frame that this PC wants to send this little frame. This little frame will go and stay in its egress queue, and this is where it gets tagged. So it will go in its egress queue. When it gets to its egress queue, the queue will go, oh, when you configure this port, you configured it as switch port access VLAN 20. So this is where the tagging takes place. So the switch will go, because I've received the frame on this port, putting it in a egress queue, I will tag it with VLAN 20. And that's where the tagging is. But then when a frame is coming in here, because the PC has absolutely no idea what a tagged information is. If a PC received, or typically, if a PC received an information with a tag on it, you probably drop it. Why? Because the frame is bigger than a normal frame. It's got 4 extra bytes in it. So it'll be like, yeah, what information is this? I'll just drop it. It's an irregular frame. But if a frame is coming in, this is the ingress port. A frame is coming in from another machine. It goes through the switch back plane. Before the switch places it in this ingress queue, it takes away the tag information and then put it in this ingress queue on the port. And then it goes out and the switch. So the PC doesn't know I'm on access VLAN 20. It's only the switch that knows that this port has been configured for VLAN 20. So anything that comes into this egress queue, I'll tag it with VLAN 20. Anything that comes into this ingress, anything that is for VLAN 20, I'll send it into the ingress queue of this port, but then I'll remove the tag before I place it there. So that's like the basics of like how the whole thing operates.
Yep.
Yeah. So yeah, nice one, guys. I mean, we're making progress. I mean, we understand switching much more than when we first started. The whole purpose of this whole switching series is we understand CCNA switching more. And I'm thankful that we are getting more information about how it works in the real world and that. So after we finish like with the whole switching series, we go to the CCNA routing series. Then, if time allows us, we'll also go to CCNA troubleshooting series, where we'll do labs every Sunday. We just do
So with
labs.
that that question that we just did,
Mm.
if those were not access ports, then that would not be a valid.
Yeah. If it's
Yeah,
not
exactly.
access
You're
port, it's
right.
going to drop it.
Yeah,
Okay.
because if it's a trunk, it will get the problem. What problem do you think it will
No,
get?
no. Even if it's not an access port, if it's just a VLAN port 20, right? Let's
Yeah.
say we don't configure switch port mode for it. We just assign VLAN 20 to the port,
Yeah.
right?
Mm.
And it's not a trunk. Let's say it's not even a trunk port.
Mm.
For some reason, let's say it's not even a Cisco switch port. Let's just say it's a ordinary switch that has VLAN 20 assigned to it. The fact is that if it's a switch and you have assigned a VLAN to that port,
Mm.
for that port, anything that it sends out of that port is going to be tagged.
Mm.
It's going to have that VLAN information on it.
Mm.
And